Welcome to Emtron Training Part 20. In this training tutorial, we're going to take a look at working with our Lambda Correction within our Emtron ECU. The Lambda Correction is going to allow us to take a look at a Lambda sensor that's fitted into our exhaust stream, compare it against the target Lambda, and allow the Emtron to make percentage adjustments against the injector pulse width that we're calculating in our fuel and airflow modeling. This is going to correct any kind of deviations day to day or seasonal changes or any kind of conditions where the fuel mixture might vary from the command Lambda target. We're gonna have a lot to cover taking a look at our Lambda correction. Let's jump in so we can check this out. Okay, so let's get started. We're gonna be taking a look at working with our closed loop Lambda control within our Emtron system. The closed loop Lambda control is gonna be taking a look at our Lambda sensor reading. The Lambda sensor is fitted into our exhaust stream. That's going to be measuring how much oxygen content is in our exhaust stream. It's going to report that back to the Emtron. Now we have a target Lambda table of where we want to actually run at in terms of a target air fuel or target Lambda when the engine is operating at different load and RPM points. It's going to take a look at the difference between the actual Lambda that's measured in the exhaust and the target Lambda where we want to have our Lambda at. There's always going to be a slight discrepancy or difference. It's going to figure out a percentage of error and make adjustments in this closed loop O2 type format to our main fuel table. So it's going to add to our injector base pulse width. It's going to increase or decrease that in order to get our Lambda to reach the target Lambda that we're specifying. It's going to be doing that in two different ways. We have a short-term fuel trim adjustment and a long-term fuel trim adjustment. This video we're going to focus on just taking a look at the short-term fuel trim and the closed loop setup, going through all the configuration details. The next video we're going to be then dedicating that for the long-term fuel trim control because it's slightly different. It adds a little bit more complexity on in terms of the feedback control, and we want to make things as simple as possible just so we can grasp this concept in this tutorial. So the first thing I want to do here is talk about setting up a Lambda sensor into our Emtron. Now we've covered this in a previous training tutorial, taking a look at setting up our advanced inputs. I'm going to go over it again in this tutorial so we can condense everything and keep it together. If you're coming into this tutorial to just look at how the closed loop function is going to work, I want to be as complete as possible from start to finish. First thing we're going to do is jump in here from our tuning page and move into our config. Under config here, this is where we configure inputs or outputs or turning features on or off. Now I do want to mention at this point in time, if we jump back to tuning here and we go down to engine functions, if we come down here, we're going to find that the Lambda control wideband option is grayed out. There's also a narrowband option. I'm not going to be covering narrowband because if you're doing any tuning with an Emtron system, you do not want to use a narrowband sensor. You want to use a wideband because you need that for tuning regardless. So I'm only going to cover the wideband option, but we'll find either Lambda control options are going to be disabled. We have to actually enable them, and in order to enable them and turn them on in terms of a function to actually edit and work with, we need to go and set up our wideband input. That hasn't been done yet, so let's go and take a look at how to do that. If we go here under config, and we jump into channels and then to input setup. Under our engine, we're going to find that we have two different Lambda sensor inputs. Now we also have narrowband sensors here, O2 number 1, number 2. Now, very quickly, the difference between a narrowband sensor and a Lambda or a wideband sensor. The narrowband sensors will be sending a 0 to 1 volt output, and a half a volt in that 0 to 1 volt scale is representative of stoichiometric on that particular fuel. Now, this is only valid and accurate for where we're commanding 1.0 Lambda. Once we start to command richer than 1.0 Lambda, the narrowband sensor is not going to be accurate. So the sensor is only accurate in a narrow band around stoichiometric. Now, if we're looking at any kind of performance tuning, where we're going to be varying our target Lambda as we get up into load on a turbo application, for example, going from vacuum into boost, we know that the Lambda is going to be changing a decent amount. And we need to have a wideband sensor that can report back what that actual mixture is doing rather than the narrowband. So we'll find that we have the differences here, narrowband, wideband, Lambda sensor. We're going to be working with our Lambda sensors. Now we have two Lambda sensors. We're typically going to run one Lambda sensor on a 4 or 6 cylinder inline engine. If you're dealing with a banked engine, so a V6, V8, V10, V12 engine, you're going to want to run two Lambda sensors, one Lambda sensor per bank. In this situation, I'm going to be going through the tutorial just using and setting up one Lambda sensor on a turbocharged 4-cylinder engine. So we're going to go in here to our Lambda 1, double click. We have to go to our input source. This is where we have the Lambda sensor set up and configured. Now in my case,
I have an external wideband controller. I have an AEM X series controller.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.